Let's do another calculation here. This type of question is kind of the inverse of what we've been doing so far. This time, instead of giving us a particular value for our random variable, what we're going to get is the proportion of times something occurs, and it's up to us to figure out what the random variable that causes that. So in this case, recall that we were saying that the candidates are equally supported by the community they're campaigning in. However, when we randomly select from a subject, when we randomly select from a subset of a population, even assuming the method of obtaining the random sample adheres to a good sampling process, it is possible to obtain a value that is far away, relatively speaking, with respect to deviations of the distribution from the mean. And here's the question: what is the highest possible count that separates the lower counts that occur 2% of the time? Now this is something, again, that when you start seeing these words highest, lowest, it's easy to get confused. So the first thing I want to do is create a picture and see if I can understand what this question is asking. So the first thing we do is draw our normal distribution. And again, I'm going to place in my mean. And now again, I read this over again. What is the highest possible value or possible count that separates the lower counts? So I'm looking for small values, but these lower values, these counts, occur only 2% of the time. So am I talking about this side of the curve, or am I talking about this side of the curve? Well, since the lower counts, so I'm trying to try and guess that it's this side of the curve, and I'm looking for a separator that counts, well, that separates the lower 2%. So of course, the further I go to the right, the higher it gets, and it's asking for the highest possible value that causes this separation. Now, I don't know where this value is at, but I'm going to just say it's somewhere here. Okay, here is my value, somewhere there. Again, this doesn't have to be exact. All I'm caring about is direction. So I'm going to fill in this region here, and that region is going to represent 2%. But the question is, what is this value? So this is my 2%. This value is the highest possible value, such that the numbers below it, the lower counts, only occur 2% of the time. Now the trick here is this: I don't know what this value is, but what do I know? I know my distribution is normal. I know the frequency. Therefore, I should be able to maybe find its z-score. So here's again another normal curve, but this is going to be standard normal. Again, standard normal contains z-scores. Standard normal has a mean of 0 and a standard deviation of 1 unit. So the question is, for this frequency, lower frequency of 2%, what is its corresponding z-score? Now, here's a case where it's better to use software now. The tables, are you going to find out, are very, very limited here, and the best you can do is get a rough approximation. So I'm going to use Excel to find a better estimate of z. Even using software, you're still going to have to round and get an estimate, but it's going to be a much, much better estimate. So I would type here equal to norm SINV parentheses 0.02. The output will actually give me these z-score that you see right here. Again, here's the thing to understand. This command, you enter the area, and this area is assumed to be to the left of some z-score, and what it's going to return is that z-score. Let me type this into Excel here so you can see it occurring. I type equal to into any empty cell, norm SINV 0.02, close it, hit enter, and there's my z-score. And again, I'm going to have to round this off, so I'll take 4 decimal places, so negative 2.0538. What we need to do next is convert our z-score back to a value. And the way we're going to do that is by using the following formula. This formula, again, it's a transformation. It takes any value from our distribution and converts it to a z-score. But of course, since we know algebra, we should be able to go backwards. Given our z-score, we know the mean, we know the standard deviation. We can solve for this unknown right here, and it should give us what we want. Here it is with all the values put in place. And again, notice how important the pictures are. The pictures let you know direction, and in this case our z-score is negative. But depending if you're using software, when you get your z value, it may not always be that way. So the picture lets you know what it is that you're supposed to be getting. We solve for our x value, conduct the calculation, and there is our count. And again, you notice you don't get an even count. It's 275.4, but you can't have a 275.4, so you're at a point where you need to do some approximation. If you choose 275, you realize it's a little under 2%. If you choose 276, you're a little bit above 2%. And really the choice here depends on what is that you want that number to do for you. If you want to be on the safe side, make sure that it's at least 2%, then you would choose 276. What I'm hoping I can emphasize from this problem is that you need to draw pictures. Draw pictures, shade in the areas you want. This will be a great help in trying to solve some of these problems.